These are the 1.2b pre-calc notes. Today we're going to be talking about graphing parent functions, which are pretty much just 8 different graphs that we want you to be familiar with. So we're going to make a t-chart for each so you can see why these graphs end up looking the way they do, and then we'll give you a little bit of a rule and a shortcut. All right, so the first problem, f of x equals x. We're just going to start by getting a couple of easy numbers. I like to choose a few negatives and 0 and a few positives. And then since it's equal to x, I'm just going to go ahead and write an x on the other side and copy these over. These numbers are just going to each equal themselves. And then we'll plot each one of these as an ordered pair, -2, -2, -1, -1, 0, 0, 1, 1, and 2, 2. And we can see that that makes just a regular old line. So the official name of this function is called a linear function. And when we graph these, we usually don't make t-charts. We use the rule y equals mx plus b, where m is our slope and b is our y-intercept. The next function is f of x equals x squared. So again, we'll start with an x and an x squared here. And we'll just choose again, same numbers, -2, -1, 0, 1, and 2. And then we're just going to square each of these. So -2 times itself is 4. -1 times itself is 1. 0 times 0, 0. 1 times 1 is 1. And 2 times 2 is 4. Then we'll plot these points. -2, 4. -1, 1. 0, 0. 1, 1. And 2, 4. And you probably recognize this shape. It's what we call a parabola. The official name for that function is a quadratic, but we call the shape a parabola. And when we learn how to graph quadratics, we can often use the rule 1, 3, 5. Let me show you what that looks like on our actual graph. So if we start with our point here in the center, let me go out with a different color right here. We can go up 1 and out 1 to put a dot here, up 3 and out 1 to put a dot there, and finally up 5, out 1, and that would continue a graph like that. So it creates that shape without having to do a table. And then same thing on the other side, up 1, out 1, up 3, out 1, up 5, out 1, and there's your parabola. So we'll often use the rule 1, 3, 5. All right. The next one is f of x equals x to the third. So we'll put an x here and x to the third there. And I'm going to go ahead and fill in the same numbers I've been working with, -2, -1, 0, 1, and 2. And we're going to cube each one of these, so raise it to the third power. So -2 to the third is -2 times -2 times -2. If you're going to type in your calculator, make sure you type in parentheses around the -2. This is going to get you -8. -1. 0 times 0 times 0 is 0. 1 times 1 times 1 is 1. And 2 times 2 times 2 is 8. Plot the points. -2, -8. -1, -1. 0, 0. 1, 1. And 2, 8. And what you have is this shape right here. The official name for it is a cubic graph that comes from the x squared, x cubed. And there's also a rule for this one. It's called the 1, 7 rule. And it works the same way as the 1, 3, 5 rule works on parabolas. So if you think about starting in the center at 0, 0, you go up 1 over 1. put that first dot, and then up 7 over 1 to put this next dot. And same thing on the other side. Down 1 over 1, and then down 7 over 1 to get your dot. So there's just some shortcuts you can do instead of having to make a table for each problem. All right, our next graph is absolute value of x, which absolute value, if you remember, just turns everything to a positive. So if I use the same numbers, -2, -1, 0, 1, 2, all that will happen is these numbers will all turn to positive. Some of them are already positive. You can just leave them as positive. So it's not switching the sign, it's making it positive. -2, 2, -1, 1, 0, 0, 1, 1, and 2, 2. And this one's going to make a V shape. So the name of this is absolute value. And the rule I remember here, this is just a V shape. And it just follows the rule 1, 1, 1. Up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1, etc. All right, let's look at the back side of our notes. We've got 4 more functions. First one is a square root function. So we're going to do x and the square root of x. Now the thing about the square roots, you can't take the square root of a negative. So can't square root negatives. So instead of using the regular -2, -1, 0, 1, 2, I'm just going to start with 0, 1, 2, and then maybe go up to 3. Now, as we start filling this in, we're going to kind of come to an issue because we're going to have some decimals, and I'm going to show you a way to avoid that. So the square root of 0 is 0. That's fine. The square root of 1 is 1. But if you try to take the square root of 2, you get a decimal. Same thing with the square root of 3. And I would rather not graph decimals. So what I would like us to do is take our eraser, kind of erase those numbers or scratch them out, and let's try to find numbers that we can take the square root of and get whole numbers. So the next number I can think of after 2 and 3 is 4. And if I take the square root of 4, I get 2. Then I'm just going to keep working my way up. Can't take the square root of 5 to get a whole number. So you're just essentially looking for the next perfect square. Next perfect square is going to be 9. Square root of 9 is 3. So as you pick the numbers on your table, you can kind of pick and choose the ones that work easily for you. 0, 0, 1, 1, 4, 2, and 9, 3. The official name of that is a square root graph, square root function. And this one actually follows the same rule as the parabola, the quadratic 1, 3, 5. It just is going in the out direction. So up 1, out 1, up 1, out 3, up 1, out 5. All right, our next graph, cube root of x. This is another one that's going to require us to pick some nice numbers for us. We want to take numbers that we can cube root. So we can kind of look at some of the numbers that we used on our cube graph. So right over here, we've got this -8, -1, 0. So if we kind of go opposite of that, it's going to get us the opposite direction of the cube root. So I'm just going to choose those numbers, -8, -1, 0, 1, and 8. Because I'm asking for what number times itself will get me -8. That's going to be -2. What number times itself gets me -1. That's going to be -1, 0, 1, and 2. So it's the same graph, same numbers as what we had before on x cubed, except it's just flip-flopped. -8, -2, -1, -1, 0, 0, 1, 1, and 8, 2. And you can see even the graph looks very similar. It's just kind of tilted on its side. This is the cube root graph, cube root function, and it has a rule of 1, 7. Again, these are out values, up 1, out 1, up 1, out 7. Next graph we have is the 1 over x. So we can go back to our negatives now, -2, -1, 0, 1, and 2. So if I plug in a -2 here, I get 1 over -2. That's not great. I don't really want to graph that one. -1 I can plug in, that's easy, -1. The thing about when I plug in 0, you get an error message. In your calculator, 1 divided by 0 can't divide by 0, so we don't really want that either. You can plug in a 1 to get +1, and if we plug in a 2, again, we get half, which I'm really not interested in. So what we have here, we only have 2 points, -1, -1, and +1, +1. Because of this error message here in the middle, you actually get some asymptote lines. So what happens is you get something like this and like that. And then your drawing ends up being just these little graphs right here. The official name for this one is called the reciprocal function. I don't really have a good rule to go along with this one. It's just so you got to remember the asymptote lines. That's always how I remember that graph. It has got the asymptote lines. All right, and then our last graph, 2 to the x power. So I've got x and 2 to the x. And we can try some negative numbers here, -2, -1, 0, 1, 2. If you type into your calculator 2 to the -2, you actually get 0.25. Again, not a great number to work with on a graph. If you type in 2 to the -1, you get 0.5. Again, not my favorite to work with. 2 to the 0 actually gets you 1. 2 to the first power is 2. 2 to the second power is 4. And since I had to throw out my first two numbers, I'm going to go to the third. I think we can do 2 to the third, which gives us an 8. So I'll start with my 0.01, then 1, 2, 2, 4, and finally 3, 8. And these fractions decimals over here that I kind of scratched out give me an idea of what the graph does. It doesn't go into the negatives, right? These numbers, these decimals aren't negative. It just kind of goes into these really small areas between the 0 and the 1. So it kind of like scoops along that line right there. This is called an exponential function. And this one also has an asymptote line. So let's go back. Let's call this one that has 2 asymptote lines. And the one we're working on has 1 asymptote line, which if we wanted to draw it in would be right there.